Back in 2019, the Asteroid Terrestrial Impact Last Alert System in Hawaii, also known as ATLAS, detected what looked like a typical long-period comet. It was faint, distant, and cold, but something about it was off. As astronomers started tracking it, they realized its speed and trajectory were unnatural. It wasn't orbiting the sun like everything else in our neighborhood. It was following a path that couldn't be explained by gravity alone. This wasn't just an unusual comet, it was a visitor from another star system entirely. It was officially classified as an interstellar object, only the third ever discovered. That's where the name 3I Atlas comes from. 3I stands for Third Interstellar. What made this even more fascinating was its timing. It followed two other cosmic irregularities, Oumuamua and Borisov, both of which already challenged our understanding of what's out there. But unlike the others, 3I Atlas wasn't just strange, it was chemically confusing, and that's where the mystery really kicks in. When scientists began observing 3I Atlas more closely, they started picking up something extremely unexpected. Even while it was far from the sun, too far to be warmed or activated by solar radiation, it started glowing. But this glow wasn't from ice turning into vapor or dust particles reflecting sunlight. It was from ionized metals, specifically nickel and iron. That's not normal. These metals require extreme heat to vaporize, typically above 1,400 degrees Fahrenheit, 800 degrees or more. But here's the kicker. 3I Atlas was over 20 astronomical units from the sun. That's more than twice the distance from the sun to Jupiter. No object that far out and that cold should be releasing metal vapor. And yet, that's exactly what 3I Atlas was doing. It completely defied thermodynamic norms. For a while, scientists didn't even believe the data. It had to be an error, a misread, faulty instruments. But the signals kept coming, and other observatories confirmed the same thing. This wasn't just unusual, it was impossible, or at least it was, until it happened. So how did we find out this alien comet was spewing metal? It all comes down to one tool, spectroscopy. When light from an object is broken down through a prism, or a telescope equipped with the right instruments, it reveals a unique chemical fingerprint. Every element in the universe emits or absorbs light at specific wavelengths. By analyzing those patterns, scientists can determine the chemical makeup of even the most distant objects. In Atlas's case, astronomers used the Very Large Telescope, VLT in Chile, to study the light coming from this icy visitor. Instead of the usual signs, hydrogen, water, carbon dioxide, they saw spectral lines that matched ionized nickel and ionized iron. That alone is fascinating. But here's the strange part. Usually those metals get released from comets only when they're heated, like really heated, near the sun. So how was 3I Atlas producing them while freezing in interstellar space? Researchers scrambled for explanations, and the deeper they looked, the weirder it got. With the evidence in hand, scientists began developing possible theories. The first suspects were radioactive isotopes deep inside the comet's core. Could it be that decay from unstable elements was creating internal heat, warm enough to vaporize metal? It's possible, but unlikely. The amount of heat needed would require a high concentration of short-lived radioactive material, which isn't commonly found in icy interstellar bodies. Other researchers considered another culprit, cosmic rays or solar wind particles, interacting in exotic ways with surface materials. Maybe Atlas is made of ultraporous materials that trap heat, or perhaps chemical reactions were occurring inside the object that created quick bursts of energy. But none of these explanations fit perfectly. Then came a wilder idea, a possibility drawn not from confirmed data, but from what wasn't ruled out. What if the object's unique makeup comes from conditions our solar system never experienced? Some hypothesize that Atlas formed in the far regions around a white dwarf or a system undergoing metal-rich formation processes. These environments could bake metals into the comet and trap them inside. Others wonder, could this be material from a planetary collision event? Could it have been part of something much larger, something artificial? The idea isn't taken seriously in mainstream circles, but the behavior of Atlas left the door slightly ajar. And in science, that's all it takes for speculation to thrive. It's easy to forget how rare these moments are. So far, we've discovered billions of objects in our own solar system, but only 3 confirmed visitors from outside it. Each one is like a time capsule, a sample from another star system, from thousands or even millions of years ago. When 3I Atlas flew by, it carried crystals, gases, and compounds that formed under alien conditions. That's unique. Until recently, scientists could only guess what the rest of the galaxy might be made of. But now, thanks to 3I Atlas, for the first time, we're getting a chemical fingerprint of a comet from someone else's solar system. That fingerprint tells us something crucial. The formation of materials like nickel, iron, and volatile gases is not limited to Earth-like systems. They can, and do, form elsewhere. And apparently, they can behave in ways we've never seen. This realization cracks open big questions about how other star systems form planets, moons, and comets. And Atlas might just be the first clue in a far bigger mystery. Interstellar visitor number 1, Oumuamua, was odd enough. It came speeding in from deep space, didn't resemble a comet, left zero detectable gas or dust, and then accelerated as if something was pushing it. No one could explain how. Some claimed it was just a fragment of rock. Others floated the theory that it could be an alien probe riding on light pressure. That one's still debated. Then we had number 2, Borisov. Unlike Oumuamua, Borisov looked like a comet. It had a visible coma and a tail. Its behavior made more sense, until we studied its chemical composition. Turns out Borisov contained twice the carbon monoxide of any comet we'd ever seen. Strike 2. But 3I Atlas? It didn't behave like either of them, and that's what made it even stranger. It looked like Borisov, but chemically it was closer to something forged in a furnace. Moreover, while Oumuamua was solid and lacked a tail, and Borisov was gassy but chemically bizarre, Atlas released metallic vapor, something neither of the others did. Each of the 3 interstellar objects introduced an entirely new category of strange, and scientists are now wondering, are all interstellar objects going to break the rules in their own unique way? Or are we seeing an incomplete picture of galactic building blocks? Either way, it's becoming increasingly clear. Our solar system is the exception, not the rule. Let's pause for a second, because this is where the conversation gets speculative. There's no evidence, zero verified proof, that 3I Atlas is anything but natural. But that hasn't stopped the whispers. The metals it released, nickel and iron, have industrial uses. They're the kinds of materials we use in spacecraft, in satellites, in technology. And the ionization without heat, that's something we do in laboratories using charged fields. Some in the astronomical community openly asked, was there some advanced mechanism inside? Some internal power source? Something artificial? To be clear, mainstream researchers don't support this idea, yet whispers remain. Much like the debate around Oumuamua, where the odd acceleration led to suggestions of artificial propulsion, 3I Atlas added fuel to the speculative fire by breaking another scientific rule. Ionized metals, without sunlight, it's unusual enough to trigger questions, and when space behaves in ways we don't understand, it's human nature to fill in the blanks. Whether it was natural, cosmic, or constructed, we just don't know. But what 3I Atlas definitely did was make people ask. So how has the scientific community responded to all this? With a mix of excitement, confusion, and a surprising amount of humility. Several peer-reviewed studies were published in the years following Atlas's discovery. Researchers from the European Southern Observatory, the University of Liège, and others confirmed that neutral and ionized metals were clearly present in the object's coma. One astrophysicist said, "We didn't expect this. No comet has ever released this kind of metal this far away." Another called it a wake-up call, a reminder that most of what we know about comets comes from those formed within our tiny solar bubble. And this object, it wasn't from here. Even NASA acknowledged that interstellar objects like this one will likely continue to expose gaps in our current models. There's talk now of creating new classification systems, a kind of elemental fingerprint taxonomy for categorizing unknown or interstellar bodies. Until now, a comet just meant a dirty snowball with a tail, But 3-eye atlas shows that definition may be useless when applied to the galaxy at large. Here's the real cosmic takeaway. 3-eye atlas proves that our assumptions are small. If something like this comes from another stellar system and behaves this differently, then consider this. How many planetary systems operate on foundations totally unlike ours? Could there be planets built around metal-rich stars? Comets formed entirely of chemically exotic substances? Whole systems that never made water at all? Atlas hints that the chemical blueprint for star systems might be far more diverse than we imagine. And the more of these travelers we find, the more we'll know about how rare or common Earth-like conditions truly are. Maybe we've only scratched the surface of what's possible. Maybe our idea of what space even is needs to evolve. Here's the bittersweet truth. As strange and fascinating as 3-eye atlas was, it's already gone. It passed through our solar system, danced briefly in our telescopes, and then disappeared back into the void. There was no mission to intercept it, no samples collected, no second chances. We studied it remotely for just a few weeks. And yet, in that fleeting time, it managed to rewrite entire parts of our understanding. Heavy metals in a cold comet, alien chemistry, questions we still can't answer. We don't know when we'll get another chance like this. Most interstellar objects pass unnoticed, lost in the cosmic background radiation. And the ones we do spot, they're already waving goodbye by the time we find them. 3-eye atlas may never be seen again, but the questions it raised, they're here to stay. What if 3-eye atlas had gone unnoticed? Just another blip in the telescope, another piece of infinity we never understood. It makes you wonder, how many truths have already passed us by, and how many more are coming? Objects, signals, anomalies, waiting to be studied or lost forever? Scientists believe these interstellar visitors could be far more common than we once thought. But spotting them? That's the hard part. Atlas got lucky. We got lucky. Next time, we might need to be ready. So what do you think? Was this just a weird rock from another galaxy? Or a deeper cosmic clue? Maybe even something else? Let us know in the comments. We read everything and love hearing your theories. And if you want to be the first to know about the next interstellar mystery, go ahead and hit that subscribe button. It helps us keep bringing you strange and serious space stories, from deep physics to the edge of science fiction. There's another object streaking toward our solar system right now, and let's just say, we're already seeing some strange things in the tail. But we'll save that story for next time. Until then, keep looking up